Hey, business calculus people. What we're doing today is estimating the value of a definite integral. Note that I'm trying to integrate the function t squared plus 2 between 0 and 6. And I'm going to do that using a left-hand sum and a right-hand sum with n equals 3. So let's get started. The first thing that we need to do is we need to talk about what our delta t is equal to. And our formula for delta t is b minus a divided by n. That would be a good thing to put on a quiz. Okay, our b is the 6, our a is the 0, and our n is 3. So simplifying, that means 2. What that means is we're going to be creating rectangles from 0 to 6, and all of our rectangles are going to have a width of 2. Now let's talk about the left-hand sum, which I'm going to abbreviate with LHS. Now the left-hand sum, what we're going to be doing is we're going to be drawing rectangles here. We're going to be going from 0 to 2, and in this case our rectangle is going to use the height at 0 because that's the point on the left-hand side. So I'm talking basically about that rectangle. Hey, I'll stay in blue for over this. That means I want to know what my f of 0 is. That's going to be my height times my delta t. That's going to be my width. The next rectangle I'm going to use is going to go from 2 to 4. Remember, I need a width of 2. And again, I'm going to use the left-hand side. So that will be plus f of 2 times delta t. And the last rectangle I use will be going from 4 to 6, again using left-hand endpoint. So that would be plus f of 4 delta t. Well, here's my function right here. Let's figure out what those values are going to be. So plugging in 0 into this function, I get 2 times my delta t, which is 2, plus f of 2. 2 squared plus 2 is 6, times my delta t, which is still 2, plus f of 4. Plugging in 4 into my function, I get 4 squared is 16 plus 2 is 18 times 2. So I get a left-hand sum. If you add all that up, what I got was 52. Do the same thing, except now what we're going to do is we're going to do a right-hand sum, which I'll abbreviate with RHS. It's the same idea, except now when I draw rectangles, I'm going to look at this interval from 0 to 2, and I'm going to draw a rectangle with height equal to the function at the right-hand endpoint. So my rectangles are going to look like this. They're going to be the overestimates we've discussed in class previously. All the way up here. There we go. So when I find my right-hand sum, I'm going to be looking at the area of this rectangle. I'm using the right-hand endpoint for my height. That's f of 2 delta t. For the middle rectangle, again, I'm using the right-hand endpoint. That's going to be f of 4 delta t. And finally, I'm going to be using f of 6 delta t, using that endpoint. All right, I've already know what some of these are. F of 2 is equal to 6. And then we have delta t, which is 2. F of 4 is 18 times delta t, which is 2. F of 6, plugging that into my function, I get 38 times 2. We get a right-hand sum equal to 124. So these are just like the the underestimates and overestimates that we've done earlier, except now we've got a formula that we're plugging in for to estimate the value of this definite integral. Obviously, if we used a larger value of n or a smaller value of delta t, these estimates would be better. Right now they're pretty far apart.